Welcome back to the class. I have the setup to demonstrate or to take measurements to support the previous class we had. Here in the setup, I have my power supply, I have my DC power supply, I have my ammeter calibrated from 0 to 0.6 amp and also calibrated in 0 to 3 amps. Here I have my voltmeter calibrated in volts from 0 to 15 volts. And I have the solderless board consists of resistor and also an LED, light emitting diode. Briefly, I would like to explain the circuit connection. From the ammeter, I have two terminals. One is connected to the connection wire coming from the DC supply, and the second one is connected to the first terminal of the resistor in the circuit. And this connection is a series connection of the ammeter in the circuit, because to measure current, the ammeter has to be connected in series. And to measure voltage, we have two terminals coming from the voltmeter. One is connected to the positive terminal of the LED, while the other connected to the negative terminal of the LED. Therefore, with this connection, the voltmeter is connected parallel to the LED. The first thing to do is to power our circuit. I will increase the voltage from the power supply to 5 volts to start with. Here, the ammeter appeared not to move. The pointer of the ammeter appeared not to move. Reason being that the ammeter have an internal resistance which the output current from the supply is not enough to move the pointer. But the LED is on. So this is an indication that actually there is a current that flows across the resistor to the LED, but because the current is very small, reason why it does not reflect on the ammeter because of the internal resistance of the ammeter. Then looking at the voltmeter is reading a value of 1.8 volts. 1.8 volts. So what we are going to do is to try increase the supply to the circuit. I will increase this to 10 volts. So this is increased to 10 volts. On the ammeter, we can see the reflection of the increment. The ammeter is giving 0.01 amp. And looking at the LED brightness has increased. And the voltmeter value has also increased to 2 volts. We can now use our IR thermometer to measure what the temperature is. Now focus my IR thermometer on the LED, and I have the LED temperature. I have the LED temperature to be 24.2. The LED temperature is 24.2, and the corresponding temperature, the focus is now on the resistor. The corresponding temperature on the resistor is 24.2 as well, 24.3. So it's 24.3. 24.3. On the LED, it is 24.2. 24.2. On the resistor, we have it to be 24.3. 24.3 on the resistor. 24.3. 24.5 now. Let's increase the temperature to a higher value. So I increase it to 15 volt now. 15 volts. I've set it to 15 volt. Slightly above 15. So let's try. I'll try adjust it to 15 volt. Good. We have the ammeter value increased to 0.0 amp. The ammeter value has increased now to 0.02 amps. There we go. The brightness of the LED has also increased. The brightness has increased. And the corresponding value on the voltmeter is 2 volts. On the voltmeter, we have it to be 2 volts. Let's check what the temperature is now. So the temperature has increased. The temperature has increased to 25. The temperature has increased to 25 on the LED. Then the temperature on the resistor, let's focus on the resistor now. The temperature has increased as well. The temperature has increased to 25. 25 on the resistor. I'm going to do something. I have to do it very fast. Wow, it's very hot. It's hot. So I will increase the temperature also now to 20. So I expected it to be very hot. On the ammeter value has increased to 0.031 amps. 0.031 amps. The LED also increased in brightness. Yes, the same with the voltmeter. The voltmeter has increased to roughly close to 3 volts. Close to 3 volts. We expect the temperature to equally increase. I'll focus my IR thermometer on the LED now. So it's focused on it. Wow, it has increased to 27 volts. 27 degrees Celsius. 27 degrees Celsius. Yeah, we can see that is 27 degrees Celsius. And the LED, the resistor now, I get that, yes, on the resistor now. And the resistor has also increased to 27 degrees Celsius. 27 degrees Celsius. So I'm going to try to see what 27 degrees Celsius gives me in terms of, wow, very hot, almost burnt my finger. almost got my finger burnt. So if I increase to 25 volts, what do you expect? So let's quickly do that. I increase to 25. I'll increase to 25. Wow, diameter is almost 0.1 amps. It's almost 0.1 amps. Diameter has almost increased to 0.1 amps. And looking at the LED also has increased brightness. Let's look at what voltmeter is giving us. Our voltmeter is giving us 3.2 volts. 3.2 volts. And corresponding temperature, what do we have as the corresponding temperature? The corresponding temperature is 26. 26. We have it to be 26. And on the resistor, what do we have it to be? The resistor is almost 29. Is 29. Yeah, it's exactly 29, above 29, 29.43 degrees Celsius. I dare not put my hand on this because I'm very sure it will get my hand burnt. So looking at this, we can see the effect of increasing voltage as shown on the power supply, the consequence effect on the value on the ammeter in terms of the current amps, and also effect on the voltmeter in terms of the voltage. And we could as well see what the temperature, as the temperature kept increasing as we increased the supply. And this supports Ohm's law, which says V equals IR, that I is inversely proportional to the resistance and directly proportional to voltage. So as we increase the current, the voltage increase, likewise the temperature will increase on those components. And to design a reliable and durable circuit, we must adhere to two key factors. One, component derating, as well as adherence to component parameters as specified in datasheet. So the datasheet has given us the maximum value, forward voltage maximum value, forward current maximum value, as well as the thermal resistance value. So if you want to design a reliable and durable electronics project, we must work with the rated value of components used as well as adhering strictly to the specification recommended in datasheet. Otherwise, the way the resistor is getting hot, it could eventually break down, and this will consequently affect the operation of the LED in terms of the brightness, and eventually, if not controlled, the LED can also get burnt. So I believe you have gained one or two things in this tutorial. Till we meet next time, I remain your instructor, Pupola Michael. See you next time. Bye.